Welcome back to The Explainer. Today, we're diving into the absolute foundation of modern shipbuilding. You know, before a single piece of metal is cut, bent, or welded, shipyards face a truly immense challenge. They have to prep literally thousands of tons of raw materials to build a 300-meter Leviathan. So we're going to break down exactly how modern yards conquer this massive undertaking, turning a chaotic pile of raw, rusty plates into a perfectly orchestrated assembly line. Let's get into it.
Now, I want you to really think about this for a second. How on earth do you manage thousands of tons of raw steel? If you were put in charge, where would you even begin organizing a stockyard the size of several football pitches? You've got these massive steel plates and heavy structural sections arriving nonstop from the mill. They have to be stored, tracked, and grabbed exactly when needed, all without accidentally halting a multi-million-dollar production line. It's just a staggering logistical hurdle.
To give you a real sense of the sheer scale and speed here, just look at this number, 40 to 60. That's the typical day rate for steel turnover in a modern yard. So, this stockyard, it's constantly moving. Steel arrives, gaps pop up as it gets used, and new steel has to arrive right on cue to replace it. Think of it kind of like a giant pantry in a Michelin star restaurant. Every single ingredient has to be prepped flawlessly, perfectly organized, and grabbed at the exact right second before the actual cooking even begins.
Okay, let's dive into this. Here is the game plan for today. 1. The ultimate logistics puzzle. 2. Matching steel to blocks. 3. The digital brain, CAD/CAM. 4. Choosing the right steel. 5. Flattening and priming. And finally, 6. Ready for fabrication.
Starting with Section 1, the ultimate logistics puzzle.
You see, this massive space isn't just some giant parking lot for metal. It's a living, breathing logistics machine. Shipyards are dealing with the ultimate Goldilocks problem when it comes to inventory. If you hold way too much stock, you've got massive amounts of capital just sitting out there rusting away. But if you hold too little, your fabrication shop just stops dead, and that costs an absolute fortune in idle labor and delayed deliveries. So to fix this, the really sophisticated yards use inventory software that's linked directly to the production schedule. That way, new steel is ordered automatically and shows up just in time to keep things fed.
Moving on to Section 2, matching steel to blocks.
Okay, so this is where they really bring order to the chaos. As you probably know, modern ships are built in these massive 3D blocks, and the stockyard's layout is actually designed to mirror that exact production sequence. Every single plate that comes from the mill gets logged in the materials management system, slapped with a barcode, and plot assigned to a specific structural block. And why are they so strict about this? Well, when it's time for, say, block 12 to head into fabrication, the cranes need to lift exactly those plates. No sorting, no searching around, and absolutely zero delays.
Section 3, the digital brain, CAD/CAM. All of this intricate physical sorting out in the yard, it's completely orchestrated by a powerful digital tool called nesting. Basically, nesting is the automatic arrangement of part shapes onto standard steel plates, all to minimize wasted material. It's like a giant puzzle solver. The software takes the CAD model, generates all the 2D shapes, and then figures out exactly how to cram them onto a single flat plate so that leftover scrap is kept to the absolute bare minimum.
And honestly, the impact of this digital puzzle solving is staggering. Today, a 94% nesting efficiency readout can happen in just seconds. Just to put that into perspective, a mere 5% improvement in nesting across an entire ship, that saves hundreds of tons of steel. Back before these computer systems took over, this whole process meant days of manual drawing, usually with way worse results and a ton more waste.
Which brings us to Section 4, choosing the right steel.
Now, what's really interesting about this is that you could have flawless digital design and the most perfect welding in the world, but if you pick the wrong steel, the ship is going to experience a catastrophic failure. Let's compare two ordinary mild steels used for the bulk of a ship's structure, Grade A and Grade B. On paper, they look pretty similar. Both share a yield strength of 235 megapascals, but Grade B, it offers vastly improved notch toughness. That means it has way better resistance to sudden cracking, which is totally essential for those thicker plates and highly stressed regions. And of course, every single piece sitting in the stockyard carries all this grading data.
Section 5, flattening, cleaning, and priming.
Okay, so even with the perfect grade of steel being tracked by flawless software, the plates arriving straight from the mill are usually warped, starting to rust, and definitely not ready to be cut. So they go through this wild 90-second transformation sequence. First, the hot rolling from the mill leaves behind residual stresses and this brittle oxide layer called mill scale. So the plate gets passed through massive rollers to flatten it right out. Then it gets forcefully shot blasted to strip off all that mill scale and rust until it has a bright, clean surface. And finally, it gets a super important coating.
That coating is the prefabrication primer. It's this incredibly thin, temporary layer applied literally right after the shot blasting. It's amazingly effective, completely stopping pristine steel from rusting for months while it sits out in the yard waiting its turn. But here's the brilliant part. It's thin enough that it's a weld-through coating, meaning it won't mess with those highly precise automated welding processes that come later.
Finally, Section 6. Ready for fabrication.
So, let's look at the whole picture. The raw steel has been procured, perfectly organized out in a massive stockyard, digitally tracked to a specific structural block, and physically flattened and primed. And it all boils down to this ultimate goal: draw it once, build it directly. Because they use this flawless precision logistics system, parts are drawn just one time, nested automatically, and then cut with zero human transcription errors. The end result? Way faster production, significantly less waste, and virtually no costly rework. It's a total game changer.
But, this leaves us with a massive question to ponder. If building a 300-meter Leviathan requires this level of flawless, meticulous preparation just to handle the raw materials, what in the world happens when we actually start cutting and welding these precision pieces into massive, multi-story structural blocks? How does a shipyard deal with the immense heat and distortion of welding on that kind of industrial scale? Well, we'll be exploring that incredible transformation in our next explainer. See you then.